Okay, so circumference, we're skipping the top, is the distance around the circle. I like to think about it as if you're eating a pizza, it's the crust. It's the distance of the crust if you were to lay the crust out from edge to edge. So what I have here, I have a piece of string. I'm going to cut this piece of string to fit the diameter. In a circle, there's two things you need to know. You need to know the diameter of the circle and the radius. Oh, I don't know what happened there. The length from here to here, this is called the diameter. So the length all the way across is called the diameter of the circle. So if I were to take this piece of string, it's the length of the diameter. How many times do you think I can fit this piece of string around the circle? How many times do you think it'll go around? 1 time, 2 times, 3 times, 4 times? What do you think, Aaron? If I were to make this, so if I start here, I can make this string go once, twice, almost 3 times around the circle. 3 times plus a little bit. What if I took a different piece of string, and sorry the circle got cut off, I made it the length of the diameter, how many times do you think this piece of string will fit around this circle? The same amount? This is a little harder to maneuver. 1, 2, 3 and a little. So a little bit more than 3. So it goes just a little bit past 3 times. So the diameter is the whole thing. The diameter starts from here to here. That's the diameter. If I were to cut the string in half, that would be looking at the radius. You remember the radius? The radius starts from the middle and just goes to here. That's the radius. How many times do you think if I were to cut this string in half, how many times do you think that would be able to go around the circle if it was cut in half? If it's 3 plus, what do you think? There you go. You think it would fit around the circle about 6 times. There's a special number for 3 plus. It's called pi. Has anybody ever had Pi Day at school before? Right. March what? 14th, it's coming up. Because pi is 3.14, and it goes on and on and on and on. If you go to down the hallway of Canton, the beginning of the math hall, there's pi written out. On your calculator, if you have a graphing, there is a pi button. It's like, it's hard to see, but if you hit second and then the caret, if you hit second and then the thing in front above the division sign, there's your pi button, and you can hit enter. Scientific calculators have them too. Pi is about how many times the diameter fits around a circle. It fits around pi times 3.14. And it doesn't matter how big or small the circle is. If you take a piece of string and cut it to the diameter, it'll fit around the circle 3.14 times. Pi goes on and on forever and ever. There's competitions where people recite the digits of pi and all that fun stuff. I don't do any of that. I have a poster that has all the things of pi. So pi is going to come in handy in this whole unit. So remember. So circumference of a circle. There's actually a formula to find the distance around the circle. You can either use, there's 2 of them. It depends on what you're given. Depends on if you're given the diameter or the radius. if we're given the diameter, the formula is just pi times the diameter. That's the length around the circle. Pi times the diameter. If you're given the radius, which is half as big, it's 2 times pi times the radius, 2 pi r. So pi d, or 2 pi r. You need to memorize these. You need to memorize these. Part of that formula quiz on Friday is going to be, give me the circumference of a circle formula. Okay? So, our first example is kind of like this middle school version of what you see for diameter. It just says find the exact value of the indicated measure, and then find the value rounding to the nearest hundred. Okay, you need to be careful with the directions. If it asks you to find the exact value, that means I want my answer in terms of pi. It asks you to find the exact value. So I want like 15 pi inches, 20 pi inches, something like that. If it asks you to round to the nearest hundredth, then you can actually multiply by pi. So unlike chapter 7, you won't always have decimals. Okay, but you need to read the directions. We're going to do both, the exact answer and the approximate answer. Okay, the exact answer is more exact, that's why we call it the exact answer. Because pi goes on forever and ever and ever. So for A, if I want to find the circumference, is 8 feet the radius or the diameter? It's the radius. So you got to use the C equals 2 pi r. And all we're going to do is substitute 8 for r. So C equals 2 times pi times 8. So I have to give two different answers. Okay, the exact answer is the circumference is, what's 2 times 8? Is 16 pi feet. That's the exact answer. If I want to leave my answer in terms of pi. The rounded answer, do 16 times pi in your calculator. You can just hit 3.14 if you don't have a pi button. 50.27. That's our approximate. So, this is obviously an easy question. This is why you need to pay attention to the directions. Because you should, the directions don't tell you, pick whatever one you like better. I actually like the exact answer better. First of all, there's less multiplication. Because I can do 2 times 8 in my head. So I always put the exact answer unless it tells me not to. Okay. Questions. B says to find the circumference. Is 13 inches the radius or the diameter? This is the diameter. It's all the way across. So when you see a line all the way across, it's the diameter. So we're going to use C equals pi times the diameter. So this one's real easy. My exact answer is the circumference is just 13 pi inches. That's my exact answer. Notice I'm still putting units on the end. You guys were really good in the last chapter putting units at the end. The approximate answer, 13 pi, is 40.84. So that's my approximate answer. Okay, that's too easy. C, we got to go backwards. They gave us the circumference of the circle. We need to find the radius. Notice in the circumference, is pi written there? No, which means they already multiplied by pi. So make 65.98 equal to 2 pi r. We got to solve for r. So what do you think I should do first? How do I get r by itself? Can I divide both sides by 2? Get rid of that. 65.98 divided by 2 is 32.99. That's equal to pi times r. Now what? If these two are being multiplied, what can I do? Yeah, I can divide by pi. Divided by pi. Radius is about 10.5. Something. You could do this in one step. You could take 65.98 and divide it by... The only problem is when you do this, you need to use parentheses. Otherwise, you'll get the wrong answer. If you don't use parentheses, which everybody doesn't, you get the wrong answer. So that's why it's better for most people to just keep it as 2 separate steps. But those of you who are A people, you can do it in 1 step if you want. What if I was finding the diameter? What would I do next? How would I change a radius to a diameter? Yeah, times it by 2. So the diameter here would be, you probably wouldn't even have to, never mind. Okay. So our questions won't always be as easy as these two. Because now you're in high school and the questions get harder. So like example 2. We are using, this has to do with part of the thing I skipped. We're driving a minivan. Uh-oh. How many miles have I driven after the tires have rotated through 1,000 revolutions? So, okay, if you think about a car is a circle. The tires are a circle. Draw yourself a circle. Okay, every tire on a car is a circle. And the rims have a certain diameter. 20-inch rims have a 20-inch diameter. In a minivan, the tires have a 27-inch diameter. Okay, I looked that up, just trust me. If I'm driving my minivan, I want to figure out how many miles have I driven after I've rotated through 1,000 revolutions. So think about one revolution. Let's say there's like something stuck in your tire. One revolution would be like 1 circumference. Right? So if my tire is being rotated 1,000 times, I want to figure out how far I've driven. So my first step, I'm going to figure out the circumference of my tire. What's the distance of my tire? If my tire would be laid out flat, what is it? Because this is the diameter, I'm just going to do 27 pi. But I'm going to make that a decimal, because we're going to have to multiply it and convert and stuff. 27 pi, 8482. 84.82 inches. So that's how far my tire can go in 1 revolution. It goes 84.82 inches in 1 revolution. I'm trying to figure out if it's rotated 1,000 revolutions. So my next step is I'm going to take 8482 and times it by 1,000. I'm trying to figure out the distance my tire rotated 1,000 times. 8482 times 1,000. 84,820 inches. Here's the problem. It says how many miles have I driven? I got to convert inches to miles. what's our conversion on here? Feet to miles? So I have to convert twice. I got to convert inches to feet and feet to miles. How many inches are in a foot? 12. So if I want to convert 84,000 inches to feet, I'm going to divide by 12. Because then the inches cancel. So 84820 divided by 12. 7,608.3 repeating feet. That's how far my car has gone. I'm trying to figure out miles. The conversion for miles is 1 mile is 5,280 feet. So I'm going to divide again. So now I'm going to divide by 5,280 feet. So the feet cancel. So I drove approximately 1.33 miles when my tires spin 1,000 times. So imagine how long your tires spin if you drive like to Chicago. That's why potholes are so dangerous. Because one revolution and you're out. Okay? The bigger the tire, the farther you go in 1,000 revolutions. Right? Okay. So we're going to have a lot of story problems. Let's try another one. Here we have a satellite around the Earth. It's in a circular orbit about 200 miles high. Assume the radius of the Earth is 4,000 miles. If it takes the satellite 2 hours to make a complete revolution, then how fast is the satellite going in miles per hour? So you basically have two circles here. You have the circle, that's the Earth, with a radius, of 4,000 miles. That line shouldn't be all the way across. It should be halfway. And then you got the satellite going 200 miles above it. Here's our satellite. "200 miles above it" means the distance from where the Earth ends and the satellite begins. This little section right here is 200 miles. And this should be just the radius. So the question says, if it takes 2 hours to go around this whole track, okay, to make a complete revolution, how fast is the satellite traveling in miles per hour? So we got to find the distance of the outside circle. Okay, we're going to find the circumference of the outside circle. So circumference is 2 pi r. What's our radius here? Is it 4,000? Is it 200? Or is it 4,200? Your radius should always go from the center of the circle out. So even though we're using this big circle, our radius is these two pieces put together. Does that make sense? So our circumference here is 2 pi times 4,200. Because the satellite is 200 miles past Earth. So you got to take the distance from the center of the Earth out plus the 200 miles. I'm going to just multiply this all out and get a decimal. $26,389.38 miles. So that's what the satellite has to travel in one revolution. It traveled all that distance in 2 miles. 2 hours. 2 hours. So if I want miles per hour, I'm going to take this number and divide it by 2. That'll give me miles per hour. So the satellite's going 13,194.69 miles per hour. So there are times where you're going to have to convert. Like I said, it's not going to be easy. Just here's the circumference, here's the radius, find the circumference. Here's the diameter, find the circumference. Okay. I got to make the problems a little harder. Let's try the next one. So given the height of the tennis ball, so we have 3, in this picture we have a 3-pack of tennis balls. Okay, there's 3 tennis balls in this tennis ball can. The whole height of the tennis ball can is 9 inches. What's the circumference of just each tennis ball? So think about, there's 3 of them in each can. So if the whole distance is 9, and there's 3 of them in there, what would be like the diameter of each? Yeah, each one would be 3 inches. Say, stack on top of each other. So now you're just finding circumference when the diameter is 3 inches. So our circumference is just 3 pi inches. Or 9.42 inches. We got one last problem. Okay. So everybody's run around a track before, right? You all have taken gym. An indoor track we have is 70 by 170 meters rectangle with 2 congruent semicircles. The semicircle is just a half a circle on each of the short ends. What is the distance around the track? So the track kind of looks like this. You got like a rectangle that's 70 by 170. And then you got 2 half circles on either end. Normally, like a track, like a football field, is 400 meters all the way around. We're trying to figure out the distance around this whole track. If I'm going to run around this track. So we have to do some addition. I already know I have the 70 and the 170. Or the 270, sorry. The distance around the track, I already know I have to go both 170 meters. From here to here, from here to here. The problem is I got to find the distance around the curved area. But what do you think happens if you take 2 half circles and you put them together? You get a full circle. So can I find the distance if I were to take these 2 half circles and put them together to get a full circle? What do you think the diameter is there? 70. It's this other part of our track. So I took the edges, imagine this goes away, put it together, you get a circle with a diameter of 70 meters. Does that make sense? So if I find the circumference, it's just 70 pi. Pi times the diameter. I get 219.91. So I'm going to add that to my distance I already ran. So if I start here, I run 170 meters, then half of my 219, 170 meters, then half of my 219. So if I were to run one lap, I run 559.91 meters. Okay, so this track is slightly bigger than normal. And you see this kind of stuff all the time. If you've ever been to the airport, when you go to pick up your luggage, those tracks are kind of circular. Any kind of, like, speed skating, you could do it for hockey rink. So you kind of create a circle from the two half circles. Question?